And we are live on the first Fab Lab Maker Hub Facebook Live session. Thanks everybody for joining us today. This is going to be a kind of semi-regular event. We're going to be running a Facebook Live session every Tuesday morning for the next 4 weeks. We're going to be looking at the different technologies we have in the Fab Lab, and we're going to be talking about the kinds of things that you can do with the technology, the kinds of products that you can make, and how to use it to kind of prototype your own products. So this week is laser cutting. Next week, we're going to be talking about 3D printing. The following week, we're going to be talking about vinyl cutting. And then the last week, I'm going to be joined by my good friend and colleague, Leo Scarf, and the pair of us are going to be going head to head to talk about product prototyping and how to use all these technologies to make your own products. Okay, so like I say, this week is about laser cutting, but I understand that maybe not everybody knows what Fab Lab Maker Hub is all about. So here's a little video that we put together just as a little kind of teaser to get you up to speed on what this Fab Lab Maker Hub thing is all about. So I'm just going to roll the video. Roll VT, as they say. Okay, so here we go.
Fab Lab Maker Hub is a mobile Fab Lab funded by the Upper Shannon and Arun Future Economies project. It covers a geographical area of counties Leitrim, Cavan, Longford and Roscommon. Its aim is to provide increased access to digital fabrication technology and deliver training on design skills, design thinking and digital fabrication. Fab Labs are a global network of nearly 2,000 digital workshops that share a common set of tools and technologies. The concept originated at the Center for Bits and Atoms in MIT. The goal was to provide access to the tools and knowledge to educate, innovate and invent using technology and digital fabrication to allow anyone to make almost anything, and thereby create opportunities to improve lives and livelihoods around the world. Fab Labs focus on desktop digital fabrication tools and open source electronics for prototyping and invention. Contained in our mobile Fab Lab, we have 3D printers, a 3D scanner, a 40-watt CO2 laser cutter, a vinyl cutter and plotter, a heat press, and assorted programmable microcontroller boards and robotics kits. The Fab Lab is available for people of all ages, backgrounds and experience. We work with schools, community groups, small businesses and individuals, and offer short, informal hands-on workshops, training courses in product design, prototyping services, and educational STEM events for families and young people. Fab Labs are perfect for creating one-off, personalised products that you won't find in the shops, or learning a new skill to help your career or business. You can create your own branded t-shirt design, make a sign for your business or home, make personalised jewellery or gifts to keep or sell, prototype a new invention, 3D scan yourself, or just tinker with Tinkercad and 3D print something unique. Fab Lab Maker Hub. Take your ideas and make them a reality.
So there we go. That just gives you a bit of a overview on the Fab Lab Maker Hub project and what we're kind of trying to attempt to do with the technologies and the tools and the knowledge that we have here. So just to talk about laser cutting, but I guess I have to kind of like reverse back up a bit and talk about, you know, what digital fabrication and maybe CNC machines are, because laser cutters are CNC machines. Those are what's called computer numerically controlled. So basically, digital fabrication is anything where you have a computer controlling a machine to make something. And a laser cutter is a CNC machine, a computer numerically controlled machine. But what is a laser? Well, lasers were invented back in the 1960s. And laser is an acronym. It's one of these sort of words made up from other words. And it stands for light amplification by stimulated emission of radiation. What the hell does that mean? So basically, it's a way of focusing a beam of light down to a very narrow focus beam at a very narrow wavelength on the light spectrum. And by doing that, it amplifies the power of the light. So it absolutely intensifies it to the point that it can basically burn through things. The If you think about the sun on a very sunny day, I don't know if anybody's ever done this. I've done this as a child. I know if you got a magnifying glass and held the magnifying glass up on a really sunny day and focused the beam in the magnifying glass, you could kind of set a leaf on fire just by the power of the sun magnifying the light on through the magnifying glass, onto sort of the material. Essentially, that's what a laser does. You're focusing it down. Now, there are lots of different ways that lasers can generate light, and therefore there's lots of, sort of different types of laser cutters. Now, what we're talking about for our purposes in the Fab Lab are desktop laser cutters. So basically things that can actually just fit on your desk at home. These are they're kind of heavy machines, but they're kind of small enough that they would, fit in an office maybe. The types of lasers that we're talking about, the actual laser tubes themselves need some kind of a gas inside them, like a fluorescent light bulb, has kind of neon inside it to illuminate. The laser cutters use a type of gas to create the vacuum it needs to create that light beam that gets focused. And one of the most common types for desktop laser cutters is CO2. So we have CO2 gas inside the tube of the laser cutter. There are other types of laser cutters that use sort of fiber optic cables. Some of them even use a particular type of crystal, kind of solid state crystal, and others actually use what's called diodes. Essentially, if you think of like an LED, that's a light emitting diode. It's the same kind of idea. You have a light emitting diode, but again, it gets focused to a very narrow kind of wavelength. So laser cutters come in different types of power as well. So if you think about the kind of laser pointer that you might have for doing presentations, that would be a diode laser, and it's a very low powered. It's say like 1 milliwatt in power. CD players have lasers in them, and they're very low power as well, about 5 to 10 milliwatts. And then moving up, you have higher powered diode lasers that would be used maybe for sort of engraving machines, and they're about 1 to 5 watts. And then moving up again to the sort of desktop CO2 lasers that we kind of use in the Fab Lab. Those range from about 30 to 150 watts. And then you have huge industrial lasers that would use maybe sort of the solid state crystals or the fibers. And those would go from anything from like 150 watts up to, say, 3 kilowatts. So there's a whole range of powers of laser there. Now, lasers are dangerous. There's no doubt about it. Certainly at the sort of higher powers, they can be very dangerous. So this is why they kind of class lasers into different kind of classes. You have class 1, 2, 3, and 4. Essentially, class 1 lasers would be the safest, and they're either low power or they're enclosed in some way so that the laser beam can't actually get out of the box. So CD players and the desktop laser cutters that we're talking about would be class 1 lasers. because they're either a low power, or if they're a higher power, they're enclosed in a casing where you can't actually physically get access to them. Or there's sort of fail-safe mechanisms like power shut-off. If, say the lid of a laser cutter is lifted up, that cuts off the power to the laser. Moving up, you've got class 2 lasers. These are kind of like what's called safe open lasers. Again, these are low power. So the laser pointers I was talking about, where you can shine and point at screens, those would be kind of class 2 lasers, laser pointers. Anything where you can actually point it. Now, those lasers, you shouldn't really look a laser in the eye because there is a chance that it can cause eye damage. Now, class 2 lasers are meant to be safe enough that you can kind of glance at them and you can look at their reflected light, but you shouldn't really look at them for anything longer than about 5 or 10 seconds. Then moving up, you have like class 3 lasers. These are medium power, and they can cause eye damage. Just by looking at them, they can burn through your retinas. And then class 4 lasers, high power lasers, can cause skin and eye damage. So really, for our purposes, we're staying in those lower classes, the class 1 lasers, because we need them to be enclosed for safety. And safety is a big priority when you're dealing with any kind of, computer or, electronic manufacturing equipment. Then what kind of sizes are we talking about in terms of lasers? I'm talking about, say, a desktop laser. So desktop lasers can range from anything that's kind of, A4 size up to sort of, a few meters wide. Anything bigger than that, you're really talking about kind of industrial size laser cutters. They wouldn't really be portable. Now, laser cutters, are semi-portable. The kind of laser cutters that we have in the Fab Lab, I'll show you a picture of it in a second, are semi-portable. They can be carried by 2 people. It's not something that you can just throw in a backpack. But they are sort of transportable quite easily, sort of in the back of a car or back of a van. So if you do need to move them around, they can be moved around. Having said that, they are sort of precision instruments, so you wouldn't want to be moving them around too much, because there are lenses, and obviously the actual laser tube itself, is made of glass, so it can be damaged quite easily. So when we're talking about laser cutters, let me just switch to my desktop here, and I'm just going to show you a picture of the laser cutter that we actually have in the Fab Lab. So the laser cutter we have in the Fab Lab is what's called a laser box. So this is the unit here. This is the laser cutting unit. The bed size of our laser cutter is about A3 size. It's 500 millimeters by 300 millimeters. This little box next to it is a filtration box. Now, laser cutters, they cut, but essentially what they do is they burn through material. That's really what laser cutters do. So it's not like there's a spinning blade of some description that is actually sort of cutting through it, or like a saw blade. Laser cutters essentially burn through the material that is in front of them. So therefore, when material burns, it gives off smoke and fumes. So you have to filter those fumes out somehow. Usually there's like a big extraction fan on the back, or built into the actual laser cutter itself, and the fumes go into this box here, and that filters out all of the kind of like the gases and the kind of smells from it, and kind of cleans the air, so that anything kind of left is just kind of hot air pumped out the back. Now, filter units can come in lots of different sizes. This is quite a small filter unit, so really, if you're going to be doing lots of work, especially if you're cutting lots of wood, because obviously wood gives off lots of smoke, then you might want to use a larger filter unit. So these are kind of professional grade extraction systems by a company called Boffa, and they're one of the sort of like sort of leading manufacturers of these systems. We actually have one of these larger filter systems when we do lots of laser cutting. Okay, I'm just going to switch back to my desktop. There we go. So like I was saying, the beds can range in size from, say, A4, up to a couple of meters wide. The thing about laser cutting is certain laser cutters have the ability, although the beds are small, they have the ability to take much larger sheets of material by feeding them through a slot. And these laser cutters use a camera system to position the thing that you want to cut, so that as you're feeding the material in, it can kind of match up where it's going to cut next. So you can actually, even though the bed might be quite small, you can actually feed material into the laser cutter, and it can sort of progressively cut as it goes along. So obviously, these machines are a bit more expensive than other machines. One of these machines that's made a bit of a splash a couple of years ago is this one here called the Glowforge. The Glowforge was one of the kind of first kind of desktop laser cutters aimed at that kind of like hobbyist kind of prosumer market, and it has the ability to feed through material. As you see here down the bottom, the Glowforge Pro, you have like a slot where you can feed material in, and it can match up using the camera system in the roof there. So laser cutters are sort of like starting to incorporate much more kind of what we would call smart technology into them. Our own laser cutter has some smart technology built in, and it uses a camera in the roof, and it has this special type of material here. If you see down the bottom here, there's kind of like a QR code. When you put this material into the laser cutter, the camera in the roof identifies the QR code there, and it automatically sets all of the settings for that particular material. So this is 3mm plywood. So as soon as you put that in the machine, it identifies all the settings it needs to be able to cut and engrave that particular material. And a lot more laser cutters are sort of adding in these kind of like sort of like what they call artificial intelligence or smart systems into the laser cutter. So it makes it very easy to kind of get started. In the past, you would have had to have the first laser cutters that we had in the Fab Lab, you had a big book with loads of settings for all of the different materials you might need, and you'd have to go through and find the particular material and measure it to find out exactly how thick it was, and then type in numbers into the screen. So there was quite a bit of variables involved in setting up the machine, just even to cut something. But the new systems are kind of like taking all the guesswork out of it by adding in these kind of smart features. So what can a laser cutter do? Well, it can do lots of things. I just Googled laser cut products, and here is a Google image search on laser cut products. So I mean, there is absolutely hundreds and hundreds and hundreds of laser cut products out there. Obviously, a laser cutter can cut, but a laser cutter can also engrave as well. That's one of the things that laser cutters do very well. And I'll do a bit of a show and tell later on and show you some products that we've made. So there's a few different types of ways that you can actually use the laser cutter. And the obviously cutting is the first one. Materials that you put into the laser cutter, you cut out shapes on them. Obviously, they're laser cutters are 2D systems really, because they can just cut in a kind of X-Y direction. Laser cutters can also engrave, and when laser cutters engrave, they work very much like like an inkjet printer would. They go backwards and forwards and backwards and forwards and backwards and forwards, basically burning an image into the wood or whatever material's there. So as it goes backwards and forwards and backwards and forwards and backwards and forwards, it's quite a slow process. Cutting something is very quick because, say I'm just cutting a circle, it starts in one point and then just follows the path and goes around. But if you then want to sort of engrave a logo on there, it has to go backwards and forwards as it builds up the logo and engraves the image into it. So that's two things the laser cutter can do. A third thing it can do, though, is what's called vector etching. So if you think about cutting, again, if we just start off here and we draw a circle, it can actually cut a circle out. If we turn the power of the laser cutter down, so it's not cutting all the way through, what we can do essentially is etch a line into the material, be it the wood or the plastic, and again, that's much quicker because you're not having to go backwards and forwards. So laser etching, or vector etching, as it's called, is much quicker process. So if you need to sort of maybe make a sign which just has lettering, if you vector etch the lettering rather than engrave it, you can really cut down the amount of time it takes to produce your product. So I talked about wood as one of the materials, but the great thing about laser cutters compared with lots of other digital fabrication machines is the amount of materials that you can actually use in it. Obviously, anything that can burn can go in there, but obviously when you burn things, there's a bit of a danger that they might catch alight. So laser cutters have an extra sort of fan built in which pumps air onto the bed to keep it cool while the laser's cutting. So that kind of cuts down any sort of potential fire risk happening. Having said that, it's always good to have a fire blanket on hand when you're doing any laser cutting, just for safety's sake. But talking about the types of materials that we can use for laser cutting, obviously, there's wood like this, like plywood. Laser cutters cut plywood really well. The other thing that laser cutters cut extremely well is this stuff here, which is acrylic. I'll just show you a bigger piece here that's been cut already. So this is acrylic sheet, sometimes called plexiglass, sometimes called perspex. Perspex is actually a trade name for it. So acrylic is a kind of hard plastic, comes in sheets like this, usually about 3 to 5 millimeters thick, and it cuts extremely well. And you can make lots of functional parts out of this, but also lots of kind of decorative parts as well. You can see the board behind me over there. You can see some of the parts that were cut out. There's lighting fixtures, and there's sort of some decorations and key rings and stuff like that. So the great thing about acrylic is it comes in loads of different sort of colors and loads of different kind of textures and finishes. This particular acrylic here, and again, I'll show you some more later on. This particular acrylic here is what's called fluorescent acrylic. So when light shines into it, basically the light gets distributed out to the edges. So if you look at the edge there, it kind of looks like the edge is kind of lit up from inside. Maybe a bit difficult to see on the webcam here, but you can kind of see that the acrylic there kind of sort of like lights up as the light catches it. Again, this is brilliant for sort of making jewelry and stuff like that. Other types of materials that you can cut, obviously, you know, there's, as well as plywood, one of the kind of stock kind of prototyping materials that we use is MDF. MDF's really cheap material, comes in large sheets, and you can, you know, it laser cuts really, really well. Of course, you can laser cut cardboard, you can laser cut paper, you can laser cut sort of thin plastic sheets as well. I have some sort of like polyurethane sheets here. This cuts really well. Again, for kind of, you know, making, if I just show you here, this is a little sheet that we laser cut, and it kind of folds up and joins together. The tabs join together there, and you can make a little kind of like light, a light fitting out of that, you know, kind of hanging down light fitting with some laser cut parts at the top to hold that in place. The other thing that laser cuts extremely well is leather. You can actually laser cut material in the CO2 lasers, and you can even engrave on it. You can probably see there's a bit of an engraving on the leather. So one of the projects that we did in the Fab Lab, someone came in with a leather jacket, and they wanted the logo of their kind of like motorcycle club on the back of it, and we got the leather jacket, put it into the laser cutter, loaded up the image. I think it was like a big kind of eagle type image, and we laser engraved the image of the eagle on there, and it looked great. It looked really good. So again, that the ability to kind of customize existing products is one of the sort of main things that laser cutters can be used for. Also, another thing is you can laser cut lino. So basically, you can cut out shapes, obviously, but you can also sort of engrave into it and create stamps, basically, sort of. So here's a little kind of stamp that I made using laser cutter with the Fab Lab logo, and you can put ink onto that, and you can press that down onto a piece of paper, and it'll make a stamp. So a really easy, cheap way to make kind of custom stamps for your business or just for fun. Okay, so the other thing that you can do with a laser cutter, there's some materials you can't cut on the laser cutter. Some plastics give off a toxic gas. So any plastic that contains chlorine in it, so let's say PVC, anything with that would contain chlorine in it, you can't laser cut, because as it burns, it gives off chlorine gas, which is extremely toxic. The list of, sort of stuff that you that you can't laser cut is quite short. So basically, anything containing chlorine gas, you can't laser cut. The other thing you can't laser cut is something called polycarbonate. Polycarbonate is like a kind of is a very hard plastic, like acrylic, but it's much more similar to glass. And that does not really laser cut well. The temperature at which you need to cut that is actually too high. Also, some materials can't be cut in the laser cutter, but they can be engraved. So glass is one of those materials that you can't actually cut in the laser cutter, but you can actually engrave on it. And the best way to actually engrave on glass is to just get a little bit of washing up liquid, dish soap as they call it, and just smear dish soap on the glass, and then you can put it in the laser cutter, and you can engrave away. And the combination of that kind of like soapy thing with the glass allows it to etch into the glass, basically. The same for metal. You can't actually cut metal on a CO2 desktop laser cutter. Again, metal's too hard a material. The melting point's too hard. But you can engrave on metal. Now, the best way to engrave on metal with a CO2 laser cutter is to have some kind of a coating on it. So you can get sort of what's called anodized aluminium. That laser engraves really well in the laser cutter. So it's aluminium with a kind of like a coating on it, and you put that in the laser cutter, and it engraves superbly well. Really does look great. You can also get a special kind of spray that you can spray onto other metals. It's called a marking kind of compound. And like, say you want to, engrave your name onto, say a piece of steel or something like that, or a piece of copper. You can spray this marking compound onto the metal, engrave that, and that leaves a kind of like almost like a sort of a black etched look to the metal. One thing I just realized that I didn't talk about was the kind of thicknesses of materials that you can cut in the laser cutter. That really depends upon the power of the laser cutter. Our laser cutter is a 40-watt laser cutter. And like I say, desktop laser cutters sort of start at around 30 watts and go up to about 150 watts. A 40-watt laser cutter is really only going to be able to cut through material up to about 6 millimeters, 6 millimeters deep. A higher power laser cutter, like 150 watt, would easily be able to cut through maybe kind of 10 millimeter material. Now, if you want to cut thicker materials in a lower power laser cutter, there are workarounds. And the workaround basically is to just run the job twice. So cut once, and it will go down to a certain depth, and then cut again, and it will go down further. The problem with that is you do end up with lots of kind of scorch marks around the material, because obviously you're kind of burning the material twice. But if that's not an issue to you, then it's certainly a way to kind of get around the limitations of kind of lower powered laser cutters by sort of running a couple of passes on the job that you're trying to do. I guess what would be good at this point is to actually show you a laser cutter in action. So over the summer, we made a series of videos. The Hive in Carrick-on-Shannon were good enough to lend us one of their rooms and equipment, and we set up what we call a pop-up fab lab in the Hive, and we recorded quite a few videos that are sort of slowly going up on our YouTube channel. Got to give a plug to the YouTube channel. That's Fab Lab Maker Hub on YouTube. So we did a little sort of intro to laser cutting. So I'll just run the video now, and you can just get a look at the kind of things I'm talking about here.
Hi, welcome to this Fab Lab Maker Hub video, another in the pop-up Fab Lab series. Today I'm going to be going through laser cutting, and I'm going to be using our laser cutter here to design a simple product and get it cut out on the laser. Okay, let's get started. This is the laser cutter here. We have our material all ready to go. That's hooked up to our fume extraction unit. That's going to extract out all the fumes and filter them and pump them out the back there for us. I have my computer here. What I'm going to use is Inkscape here, and what I'm going to just design is a very simple design for a little kind of like name plaque maybe. So I'm just going to draw a little circle here on the screen. I'll zoom in so we can see that a bit bigger. That's going to be the outline of my plaque. And what I want to do is maybe just put a little hole in the top there, so if I wanted to I could turn it into a key ring even. And then I'm going to type in Fab Lab. I'm going to come up and just change the font. Because the laser cutter will cut out the outline of the letters for us, I want it to be nice and bold. There we go, that's perfect. And I'm going to put that in the middle there, Fab Lab. Okay, so I'm going to save this file as a SVG file. SVG files are the standard vector graphics file that the laser cutter uses. So I'm just going to call this Fab Lab and hit save. Just going to go back into the laser cutting software. So this machine is called a laser box, and this is the software that controls the laser cutter. At the moment I have the cardboard in there, but what I want to do is cut this out of plywood. This is plywood sheets. It has a kind of like a coating on the front of it. This laser cutter has a special feature built in whereby it can identify the material using this kind of QR code. So when I put the material into the machine, it will actually identify that it is 3mm and it's plywood. So let me put that in now. There we go. It has a camera built into the roof which looks down onto the bed. As we do this, it will actually update the screen there, and it's actually identified there for us that it's 3mm basswood plywood. So what I'm going to do is import my design that I've just saved onto the desktop, Fab Lab. There we go, that's loaded that in now. Now that I can actually see the bed here, I can position my file wherever I want it. I can actually change the size of it as well if I want to. The two different coloured lines, the purple line is going to be a cut line, so it's going to cut out the outline, and the line for the Fab Lab is going to engrave those for me. So once that's all set up, I can hit the start button, and it's going to calculate how long that's going to take to do that. So I'm going to send this over. There we go. Now all I need to do is just press the button on the laser cutter and it's going to start working. The fans will start up so that it can extract the fumes, and the fumes will go through into the filter and they'll get extracted out. So we'll just wait for that to finish. It's very quick. Now it's going to cut the shape for me. There we go. Now there are some fumes in there, but they're being extracted out now. The fan ramps up at the end there just to filter out the last remaining fumes. And it says our job's finished. So I just click OK to that. So now I can take this out, and there is my finished piece. I can take the covering off that. A little bit tricky to peel, but essentially you get the idea. Fab Lab.
Okay, so there you go. That gives you a bit of an idea about the laser cutter we use, the LaserPox. So the software that I was showing there, just moving on to talking about the kind of software that you would need to, if you wanted to design something to cut out on the laser cutter, I was using a piece of software there called Inkscape. This is the Inkscape website. Inkscape is what's called a vector graphics file, vector graphics package. It creates vector graphics files, those SVG files, or scalable vector graphics as they're called. The reason we like using Inkscape in the Fab Lab is because it's open source software, so it's developed by a community of users. So it's constantly being kind of worked upon and updated by the people that use it. So that's good. It's free to use. It's free. They do ask if you use it for commercial purposes that you contribute. There is a big contribute button on their website. Obviously, the people that develop it, they do it for the love of it, but they also like to get paid as well. But like I say, it's really great software, and you can download it for free and use it to create your files. If you have something like Adobe Illustrator is very similar in terms of the features. Inkscape, Adobe Illustrator, CorelDRAW, they're all what we call vector drawing packages. The reason we need vector drawing packages is because we need those lines that the laser cutter can follow to cut out the files. Also, the other great thing about Inkscape is there's lots of kind of plugins for Inkscape that are being developed as well to create shapes. So if you want to create sort of geometric shapes and patterns, there's lots of kind of plugins available to sort of automatically generate those kind of things for you. So like I say, if you're getting started and you want to sort of dive in to sort of start designing for laser cutting, then a great place to start is using something like Inkscape to do that. Okay, let's switch back. So where's laser cutting sort of used? A lot of sort of businesses that use laser cutting use it for the ability to kind of personalize products, and to be able to quickly change a design and cut out a different shape. So say you're making, for instance, a coaster design for a bar or a restaurant, and the restaurant needs 20, 30, 40 of these, but say they want each coaster to have a different number on it for the different table. It's very easy to personalize those designs so that it has numbers put on it for the different tables. Say that's just one example. Again, like if you're personalizing products for as gifts for people, you want someone's name put on it, then it's very easy to create personalized products, be they sort of whatever, leather goods or whatever, to put a particular name or a logo or whatever on there, or a message on the things. A couple of the local people This is local to me up here in Leitrim and Sligo. Louise Carroll. Um, Louise runs a gift business in Drummerhare here, and she was on our podcast. She was the first guest on our podcast, and again, I'm going to have to plug my podcast, I'm afraid. Yeah, again, over the summer we recorded a podcast with lots of different kind of artists, designers, and makers who use digital fabrication in their work, and we got them to tell the story of how they got started. So you can check out the podcast. There's 7 episodes available, and there's another few episodes on the way soon. So Louise was the first guest. You can find that on all the usual kind of podcast platforms, Apple Podcasts, Spotify, Google. So go check that one out. It's really good. This is Louise's website. So Louise sort of specializes in using slate, and she uses a combination of kind of methods. One of them is laser cutting and laser engraving. She uses sandblasting as well, and for that she uses the vinyl cutter. So I'll be talking about that in a couple of weeks' time when we come on to vinyl cutting. But you can see here, this is something that she would do with the laser cutter here. So something like this, a personalized street map. So basically, you can tell her where you live, and she'll download the map and then personalize it for you, and create a lovely kind of like gift product there using laser engraving to do that. So again, it's a really kind of quick way of getting products personalized using the laser cutter. Another person that we interviewed on the podcast was Orla from Nut Job Design. Orla's in Sligo, in Strand Hill, and Orla uses her laser cutter to make some really kind of fantastically intricate designs. She started doing these mandalas, which are these really fantastic intricate patterns that you can put on your wall as a decorative object. And she has lovely packaging to go along with them as well, that she uses the laser cutter to design as well. So these are fantastic gift products. But she also does, again, she does personalization. So she can do personalized gifts where, you can have a name for your child, like a sign for their door or whatever, or some kind of hanger. All these kind of personalized gifts can be done, really quickly and easy using the laser cutter. So personalization, that's one thing that the laser cutting is great for. The other thing is to create functional products. When you laser cut, the laser cutter has such a precise cutting ability that you can make products that basically sort of fit together like 3D jigsaws, without using any kind of glue. They literally just are held together, what's called press fit. And the company that I think kind of exemplifies this is a company based over in Eastern Europe called U-Gears. I'll just switch to the U-Gears website. Here we go. So this is the U-Gears website. So U-Gears create these essentially kind of like 3D jigsaws. All the parts are laser cut, and they come on a sheet, and the parts are kind of pressed out like one of the old kind of Airfix kits, and you can put them together and they actually functionally move. They have like clockwork mechanisms in them um, to create functional products like this. So obviously these are kind of like gift products, but obviously you can create, functional products that, that can be used, for more than just kind of decorative purposes as well. And again, I'll show you some of these in our show and tell in a little while. Moving back. So the other thing about laser cutting is that they can be combined with, say, electronics items to create, say, lighting fixtures, to create sort of mechanical gears and objects like that. You can also take existing objects and and make sort of other products out of them. Again, I'll show you some in a little while. Lastly, the other thing that laser cutting is really good for is jewelry. Like I was saying, the acrylic. Again, you can see here these little kind of Christmas tree shapes and snowflakes. These were produced for a school last year, the student enterprise awards, and they were producing laser cut earrings to sell at their school Christmas fair. And they did really well. This was the local school to us here in Manor Hamilton. So I'm just going to move over to the other camera here now, and we'll go through some of the products that we've made on the show and tell. So give me 1 second, and let's move over to the camera here. So on the table in front of me, I have a whole load of products that were created on the laser cutter in the Fab Lab. I'll take you through some of them to start off with. So just one here in front of us, just to show you sort of like how laser engraving can create, some really nice. This was created for my son's bedroom door. He was much younger then, and he was big into tractors. And I found an image of a tractor on the internet, and we downloaded it, and he picked that one out specially, and we laser engraved that, and then cut around the outside, put his name on there, and then just a bit of Velcro on the back, and that's been stuck on his bedroom door for quite a while now. So again, nice little kind of idea there. Here's something else as well. So this is a laser engraved chopping board. So the chopping board was just bought I think it was bought in Lidl actually, just as a bare chopping board, and you can buy these online very cheaply. Again, I found a nice design and embellished it with some texts and added in some sort of curly cues around the edge. Laser engraved that onto the chopping board, and you've turned, essentially what is a very plain chopping board into a nice kind of, gift item. Something that Leo kind of invented here. Again, like we were talking about laser cutting, you can make parts that kind of like slot together. So this is just a little kind of toy, child's toy. It's a little kind of sort of what they call a trebuchet. So it's just essentially sort of 1, 2, 3, 4, 5, 6 parts, and then a rubber band around it, and it turns it into a little kind of like catapult. So I'm just going to have a go here so I can catapult my little robot figure across the room. 3, 2, 1, go. Yay, perfect, works well. So again, very easy. Again, here's another design that Leo made. It's a little phone stand that can be made into a key ring. So there's a hole there, you can put a key ring through it, and the two parts just slot together like that, and then you can stand your phone up in it. Don't have my phone here, so I'll just stand up this little thing here, but so you can use it as a little phone stand like that. And again, when you're finished with it, you can take it apart and put it back on your key ring like that. Talking about the jewelry, so again, here's some jewelry, some earrings that we designed. These are cut out of the fluorescent acrylic that I was telling you about, and I'm not sure if you can see there, but as they kind of like dangle about, the light kind of catches them, and they really show up nicely. Other things that you can do, obviously, we're talking about functional products. So this is a little laser cut robot kit. So this is a little computer board called a microbit. They're very popular in schools for teaching coding, and you can buy this kit, and it comes just with laser cut parts. All these parts here, the white and the green parts, are all acrylic. Again, that's laser cut, and they can be bolted together. They literally just slot together, and there's two motors inside, and that turns that into a little robot that you can control using some software. The other thing is, as I was saying, like the U Gears website, they produce sort of functional products that you can make by punching out parts out of a sheet. So here's an example of one that we kind of did ourselves. This is parts for the geodesic dome that you might be able to see in the foreground there. So when we send out the kits to people to make our geodesic dome, they come on a sheet like this, and then people can just punch out the individual struts out of this sheet and create the dome. Here's another example of one where I've kind of started punching out the sheet. This is a kind of like just a kind of a geodesic structure that makes a kind of a nice kind of sort of a round pattern like that, and you can punch out these parts. So I can just punch out the individual parts like that, and they pop out really easy out of the sheet, and then you can slot them together. Again, because of the laser cutter is so precise, the parts kind of slot together and they don't fall apart. As you can see, I can shake it around there, and those parts are really nicely firm together. And then you can, pop them onto here like that, and they go together. The other thing you can do with a laser cutter is take, like I was saying, take existing objects and turn them into something new. And one of the things that we like doing in the Fab Lab, and we run workshops on it, we've run quite a few workshops on it, is creating clocks. You can buy these little clock mechanisms for about €1 each. They're really quite cheap to buy, especially if you buy sort of a pack of 10. They're very cheap, and you can then turn that little clock mechanism into a really nice, decorative clock. Make whatever pattern you can think of. Again, there's another one there, a different kind of pattern, and even my favorite here, using the combination of kind of laser engraving. This was actually a present for my father, who might be watching today. Hello, Dad. He's a big rock guitar fan and blues fan, and I made a clock for him with his favorite Flying V guitar there. Other things that we've made in the Fab Lab. I'm just going to bring a couple of bits and pieces around here to show you. As I was saying, like the laser cutter can, also engrave onto fabric. You saw I engraved onto the leather earlier on. So here is a piece of denim. This is from an old denim jacket of mine. I literally just cut it out and found a nice design and just laser engraved the design onto the denim. So again, you can kind of take, maybe old clothes you might be thinking of throwing away, a little bit worn, and you can do a bit of kind of upcycling on them and turn them into a really nice kind of product, or of your own. Now, this thing here, at the moment we're running a course, it's called a musical contraption course, and basically we designed this little mechanism here, that comes as a kit. Again, all the parts kind of get punched out of a sheet, and the people we sent it out to put the kit together, and they can create these kind of like little kind of automata, sort of like moving sort of I guess mechanisms, using different kind of gears and cams underneath there to create things. And the idea is that you can put sort of maybe musical bells or something that kind of tinkles or jingles and turn it into a kind of like a little musical contraption. So again, this is just all laser cut from MDF, and as you can see, you can make quite functional products out of it. In terms of prototyping, as I was saying, like one of the great materials for prototyping, because it's essentially a free resource, is cardboard, and this is a little again a little kind of a prototype made out of cardboard for a kind of little toy car. Whoop, whose wheel's just fallen off. There we go. I'll put this wheel back on. So essentially, this is a little toy car. Again, made out of cardboard. And again, cardboard's a great material for prototyping with the laser cutter, because essentially, like I say, it's cheap. You can pick cardboard boxes up and cut them up, and use cardboard. But again, it's a functional kind of thing. The wheels actually do turn around there. And again, you can use this to see how your design would work if you were going to use more expensive materials, maybe like acrylic, or some kind of plywood. Other things that we've made, if I can just pull this a bit closer into the camera. This is a light here. The base of the light, if I move it forward a tad or back a tad maybe. Yep. This is a light. The base is made from layers of plywood, and there is an LED lamp in the bottom of it that shines up through slots in the top into some of that fluorescent acrylic I was talking about earlier, onto which we've etched a design, and as it shines up, the design kind of lights up. So these make, again, fantastic kind of like gift products, and you can have all kinds of shapes and designs to this, just using a simple kind of LED strip shining up through the edge of the acrylic. The other thing you might be able to see here is a little clock. This is the face of that was laser cut, and again there's an LED matrix behind there that's held in place, and a little small microprocessor board called an Arduino sort of writes out the time in letters on the front there. So again, another kind of like simple kind of little idea that, you know, that whole clock to put together in terms of the parts and materials would be something like 10-15 euros. And I've seen these clocks sell on Etsy for sort of upwards of 60 or 70 euros. So again, just an example of the kinds of things that you can do. One last thing I'll just show here is again just a little kind of personalization. This was just a little sort of like food storage container. Again, I think I just picked up in one of the little kitchen shops. Wasn't very expensive, maybe a couple of euros. The lid is bamboo. It's very nice kind of bamboo. And again, just using the laser engraver to engrave the words into the top there, herbs. So again, you can personalize sort of existing products very easily, just using the laser engraving. So that gives you a bit of a rundown. I'm just going to switch back now to the other screen, and we'll see if there's any questions. Okay. So, I'm just reading some of the comments here. Hope Santa has a load of laser cutters this year and brings one to my house. Absolutely. Well, if you wanted to buy a laser cutter, I guess that's one thing. That's one question that someone has just messaged me there. How much do they cost? Well, that is a good question. If you go on to, I'll just switch to my screen here. If you go on to Amazon and type in laser cutter, you'll see that there's laser cutters available for like £266 excluding VAT, and you think that's a bargain. That's like, you know, that's less than an Xbox, and much more useful. But the thing about these laser cutters come from China, so you're going to be waiting probably, you know, a couple of months for one to be delivered, and you have to pay import duty and tax on it. So bear that in mind. The other thing about these laser cutters is they are notoriously they're kind of notorious for being kind of unsafe. They use a cooling system to cool the laser tube down. It uses a water cooled system, so it basically pumps water around. So you have to have a bucket of water underneath the laser cutter to kind of cool the laser tube down as it's cutting. A lot of them don't have that extra fan built in to keep the bed nice and cool. So again, they're a bit of a fire risk. So these machines are kind of really only good if you want to kind of like experiment with laser cutting, but you know, definitely kind of caveat emptor, buyer beware. They're not as easy to use as they seem. There are websites on getting one of these laser cutters up and running, and as it says here, these laser cutters vary greatly in build quality and require a good deal of tinkering to keep them going. If that sounds fun to you, then you'll love it. Well, if you just want to be able to use a laser cutter, our first laser cutter was one of these machines here. So there's a company in the UK called HPC Laser, um, and they bring in the chassis for these laser cutters from China, but then they kind of retrofit them with kind of safe EU standard parts, and then put a package together around them. So, like I say, this was our first laser cutter. As you can see there, it costs roughly about 2,500 sterling. Um, so again, if you get that with a kind of a package, you're going to be looking at something around 3,000 sterling. So maybe a sort of 3,400 euros, um, or maybe a little bit more, to get the laser cutter. Like I was saying, you do have the option of something like a Glowforge. Glowforge do ship worldwide, and their most basic laser cutter starts at $2,500, which is roughly about the same in euros, about 2,500 euros. But again, you have to pay shipping and import duty because it's coming from the States. Our laser cutter, the one that we bought, the laser box, that one is, where's the price on that one? That one is, it doesn't actually say, does it? Oh yes, it does, down the bottom there. So they do two models. We have the Pro model. That's $4,000. Again, there is a company in the UK that actually distributes these now, and I believe there's a company in Ireland now that's going to start distributing them. So that's definitely an option. These laser cutters are designed for for education mostly, but they have started doing a basic version of the laser cutter. So, like I say, these ones come out, the laser box comes with its own filter unit, so you don't have to pay extra for that. But like I was saying, if you do need to do sort of, a lot of work on it, then you do really need to buy one of the big filtration units, because you'll find that the filter units will kind of run out quite quickly in a small filter unit like this. Okay, well, there we go. Is there? I can have a look, see if there's any more questions. Yes, there is. um, so someone's just asking, how do we go about using the Fab Lab to build a prototype, and is mentoring and help available? It certainly is, absolutely. One of the things that we are. Sorry, I'll just flick back to the main screen there. One of the things that we are we're able to do is provide help and mentoring to businesses via the local enterprise offices. So if you're in Leitrim, Cavan, or Longford, please go and talk to your local enterprise offices, and we can work with you to help develop prototypes for any ideas or products that you might have. If there is a particular just laser cutting job that you need doing, maybe something cut out, we can certainly do that. We're not really set up to do sort of large quantities of laser cutting. If you need sort of like a sort of short run of stuff laser cut, then I would probably point you towards, say, Louise or Orla, who have, laser cutting businesses specifically designed for kind of doing short run laser cutting jobs. and both of those are in, one's in Leitrim, one's in Sligo, so they can ship stuff. So either one of those two people will be able to do it. But like I say, if there's something that you need to just kind of prototype, you're not quite sure, you need to just try out a few different variations, then absolutely that's something that we could probably help you with on the laser cutting side. Okay, that's great. Okay, so that kind of wraps it up for today. If there is any questions, please leave a message in the chat, or absolutely email us. The email address for me is stu at fablabmh.org. You'll find all that on our website. Where's our website? There's our website. Let me put that up on the screen for you. There's our website. So again, these are some of the kits that we've made in the laser cutter. So absolutely, if you want to contact us, there's a contact us page, and there's information about news and events and stuff that we do on going to be up there. Obviously, check out Facebook, also check out Twitter. They're the sort of primary places that we use online for the social media. And yeah, do check out the podcast and check out the YouTube channel. Like I say, there's a good few videos up there at the moment, and there's more on the way. Absolutely, we got about another 10 or 15 videos in the can, as they say, ready to be edited up. So yeah, keep an eye on the YouTube channel over the coming weeks. Okay, so that's it for today. So like I say, next week we're going to be talking about 3D printing. So if you have any 3D printing questions, if you've ever wanted to find out, what I can do with 3D printing, then tune in next week, and we can hopefully answer some of your 3D printing questions. So until next time, thanks for watching, and that's been great. Cheers, bye.